My name is Shravan Kaundinya. I am a PhD candidate at the Center for Remote Sensing of Ice Sheets at the University of Kansas. I am an electrical engineering student, and we designed radars to contribute for climate change. We built various different kinds of radars that are sounders, that are surface sounders, and we put them on manned and unmanned aircraft and fly them over icy parts of the Earth like Antarctica, Greenland, Alaska, Svalbard, etc. The goal is to use these radars and gather information about this ice repeatedly every year, and then we can make inferences and conclusions based on these measurements about the ice. These repeated measurements help us in determining whether the ice is melting quickly or slowly and at different areas. Here we have a few measurements that we're doing with an antenna on a UAV. We can go inside and look at the UAV and the antenna itself. This is a VTOL, vertical takeoff and landing UAV. You can see the quadcopters here, and this makes it easier we don't need a big runway. We can just take off from any precarious position on the ice, on the glacier, on the ice sheet, and then go survey the entire area. This makes it very, very easy to go out and measure at these places. Here we have an antenna on the wing placed right here on the surface, and we have a cable connecting to the antenna right here. The radar electronics would go inside the fuselage connecting to the antenna. One of the important tests when measuring an antenna is the return loss test. This tells us how much energy is radiated by the antenna and how much energy is reflected back. This is a very important feature of the antenna, as we want the antenna to radiate all the energy that we're supplying to it. This shows the frequency and the power level at which the power is reflected back towards the system and how much is radiated towards the antenna. The great part about working at CReSIS is we employ the full project circle for each project. We design the system and the antennas from scratch. We integrate them with the aerospace, with computer science folks. So this is a multidisciplinary project where we work on different parts of the project all in the same place. We integrate these systems to the aircraft, fly them out, measure, collect data, bring them back, and then process the data ourselves. So we do the entire project cycle, and that allows us to gain unique insight into the target, that is the ice, and the systems themselves. So we have a synergetic research that is both electrically technical, aerospace technical, and geologically technical.